of the 10 million, sorry, of the 30 million, about 3 million, about 10% are machine learning engineers. And that has grown from about 1% 5 years ago. So in the last 5 years, the number of developers who are building with machine learning has increased about 10x. Now, these numbers are important because particularly the first number, the 30 million, because if you think about the economy of the world today and how much of it is driven by tech, that's on only 30 million people out of a population of over 8 billion. So it's a very small minority of people are the thin end of the wedge or the fulcrum that in many ways are driving the economy. And the fastest growing group of these is machine learning engineers. But what has happened in like recent months is the emergence of this new group. It's the emergence of this new group that I'm going to call model users. So when you use machine learning, when you train something, as I was talking about earlier on, you're not building an app or a program, you're training a model, and then that model is able to react to data and produce a prediction on that data, and that prediction is artificially intelligent. It's emulating like conscious intelligence. It's emulating how an intelligent being would react to that data. So like a picture, like I've mentioned, or even a sentence, like if I say the words, "If you're happy and you know it, what would you respond?" You're all very quiet, but I'm going to guess you're responding, "Clap your hands," because you are an intelligent being. You've heard that phrase before and you would respond in that way. There's a machine learning technique called transformers, which learns how some pieces of text transform to other pieces of text. So if you ask it, "If you're happy and you know it, what would the next piece of text be?" It has learned that the next piece of text would generally be "clap your hands." And that T for transformers is actually the T in GPT, which is generative pre-trained transformers. And it's a machine learning technique, again, for creating models that can respond intelligently the way an intelligent being would. So it's not like when people think of artificial intelligence, we tend to think of it as what we see in sci-fi, and the stuff in sci-fi is more what I call synthetic consciousness, as opposed to artificial intelligence, which in reality is much more mundane. But if we look at model users, this is a small and growing population, and these are the people who are now taking models that have been created by machine learning engineers and building applications around them. And as of today, that's still developers who are doing that. But that's going to change in the not too distant future, and I'm going to go into that in a moment. But before I do that, I just want to talk a little bit about the developers, about the 30 million folks. And the developers are the software engineers of today. And in reality, for a developer, they're the ones who know. Oh, my animation died. Let me see if I can get it to work again. Oh, it didn't work. Anyway, so they're the ones who understand that artificial intelligence is not some kind of magic pixie dust that will solve all of your problems for you. And if we look at the video that I showed earlier on of Laurence, how AI was used in that was multiple ways. So the first way was, an AI model. So machine learning was used to train a model that was first able to detect where in an image a face would be. Right? Typically it's centered, like my face is centered in the image right now, but it's not always. I might be up here, I might be down here, I might be over here. And trying to write code to first understand where the face would be is very difficult with traditional code, but with machine learning, it's relatively easy. The second step would then, and that would be a machine learning model creating an artificially intelligent application to learn where the face would be. And then the second thing would be traditional code to cut it out. Now, once you've cut it out, then again, a machine learning model, it's much easier to determine where various anchors on the face would be, where the nose, the chin, the eyebrows, those kind of things. And in the case of what we did with the application with Laurence, there's almost 500 anchors on the face. But people have different size faces, shapes of faces. Some people wear glasses, people have different colored skin, different types of hair. So that again, the way they may have beards, or they may, wear head coverings, those kind of things that to be able to write code, to be able to determine where all these anchors on the face would be infeasible. But given enough examples of faces that we've labeled with where those dots are, a machine learning model could do it. And that would be the second artificially intelligent solution in something like this. First was to find the face, and then when we've cropped it out, the second one is to determine those anchor points. And then we'll be back to traditional code to turn those anchor points, as you can see just on the left of the image here, into numeric coordinates, like where that would be as I'm moving around, and then to turn that into mouse telemetry. So this really becomes a fusion of neural networks, machine learning, and traditional code working side by side. So solutions like this one with GameFace were created in that way. It's where software engineers are firmly part of the picture and being able to use the machine learning techniques to do things that they weren't able to do before. And that's one of the explosive trends that we're seeing now, because there's a bit of a background story in Lance's mouse where it was too expensive after his house burned down for anybody to be able to find a mouse that he could use, much less configure one for him specifically. Whereas using a machine learning solution like this, a bunch of Google engineers were able to put the one together in just a few weeks and then open source it so anybody can do this for free. So again, like solutions that weren't previously feasible are now possible because of AI and machine learning. So that's traditional developers, traditional coders. There's a lot for you in this space. And I thoroughly recommend that you make AI and machine learning part of your toolbox. And because I think it should be part of every developer's toolbox, not just the 10% that we consider MLEs today. And if we talk about MLEs, so one of the things that's really important and that we consider important at Google is to be able to provide a comprehensive set of solutions so that you as a developer have everything that you need to be able to build with machine learning and create artificially intelligent solutions. And this is our ML ecosystem. There's really there's actually 6 parts to it, but when you start developing, there's 4 things that you really need to think about. The first one is data. So you keep hearing me talking about data, like if you're doing a cats versus dog, you need lots of images of cats and dogs. If you're detecting where the head is in an image, you need lots of labeled images of where the head would be. Similarly, for detecting the anchors on the face, you need data. So we've been working hard to make it very easy for you to be able to use your data and to be able to consume your data in a neural network. The second part, of course, is then developing the neural network. So creating a model architecture, defining it, and training it. I'm going to be talking in a bit more detail in a moment about one of our APIs in that, which is called Keras. But the goal is to provide free open source APIs that are extensible, that you can use to define neural networks, that are very easy to learn and use, and in addition to that, to have pre-trained existing models that you can extend for your own use. If you're not familiar with building with machine learning, this is one of the most incredibly powerful things. It's very similar to the idea of taking existing open source frameworks and extending them for your own use. But the idea is, I always like to use computer vision as an example, that there are models out there that have been trained to detect thousands of different classes, everything from a cat to a dog to a bridge to an airplane to a car. And what they've done is they've become very, very good at understanding and generalizing what it is in an image that can be used to distinguish these from each other. So that if you want to build something for a specific task, like there's one of our partners that we worked with in Japan who's a cucumber farmer, and he built a sorting machine to be able to detect 5 different types of cucumber. But instead of needing thousands of examples of each of these 5 types of cucumber and training a model from scratch, a model that was already very good at generalizing across 1,000 classes ended up being really good for being retrained to understand the difference between 5 different types of cucumbers, and it became much cheaper and easier for him to train that, and he needed less data. So pre-trained models are very, very important. Next, of course, is deployment. It's no good being able to train a model without somewhere to run it. In the video that we saw earlier on, Lance is a gamer and he has a Windows PC. And so we're able to train the model and deploy it to his Windows PC for gaming. But think about anywhere that you could think about where you would need to be able to run applications, all the way from the smallest embedded system up to the biggest scalable cloud. The idea with our ecosystem is we want your models to be able to run in any of them. And then we provide hopefully the best of breed runtimes in which they'll run. And then the fourth column is, if you are only getting started on this journey, you probably think you train your model once and you're done. But in reality, your models will need continual retraining and updating for the most part. For example, Project GameFace that I showed earlier on with Lance's face in it, there are going to be some people that it doesn't work for. There's going to be some things that we didn't think about. And actually, a funny story was, like, most of the developers who worked on this initially had darker skin than I do. And when we first started trying out Project GameFace, and I started trying to use Project GameFace, it didn't work as well for me as it worked for some of them. And so as a result, we have to retrain the model and rebuild the application. And if you're building an application that's using models, when it goes out into the wilds, there may be some circumstances where it can be improved, or there's some circumstances where it doesn't work well. And then that's the idea of setting up that virtuous cycle of monitoring and maintenance. Underlying all of this is accelerated infrastructure. The faster you can train a model, the cheaper you can iterate on that model. And then, of course, the faster you can do inference on the model. And inference means when you pass data in and it tells you something back, such as the dots on the face, or is this image a diseased artery or not, those kind of things. The faster you can do that, generally, the better. And typically, that's what accelerated infrastructure is all about. And then perhaps most importantly, and particularly with everything that we're reading in the news, is to be able to be responsible across all of these. And I do want to underline this one because often when people think about being responsible in AI, they only think about the first column that I showed, and that was the data. And if you've got clean data, you're going to have a clean application. But reality has shown that that's not the case, that you need to think in terms of being responsible across all of these things and making sure that your application works across all of these pillars. Okay, some highlights of what's new since I/O. And one of the things I want to announce that we released a couple of weeks ago is called Keras Core. Now, if you are a machine learning engineer, this is probably quite exciting to you. If you're not a machine learning engineer, sorry, some of this will be quite new. But the idea of you're a machine learning engineer is that the task of building a model that I spoke about, in some ways it's split into a stack of three things. The top of the stack is code that's very simple for you to be able to define and extend a neural network. And not that long ago, only 4 or 5 years ago, you really needed a PhD to be able to do any of this kind of stuff. I don't have a PhD, I'm a coder. And a lot of this kind of stuff has been made easy through good, easy to use frameworks to be able to define complex neural network types, like the transformers I spoke about earlier on. So it's really important for you to have that framework that allows you to easily define what a model looks like and then to iterate on that. And from Google, that's called Keras. Now, Keras has been working with a TensorFlow backend for some time, but the newest thing that we've been working on with Keras Core is, if you think about then what happens underneath that layer of where you've defined your neural network, here's where the machine learning happens. This is where you need a framework that does the heavy lifting of learning how to match data to outputs. And if you've looked at machine learning, and if you've looked at it in an academic context in particular, you see there's lots of calculus, there's lots of math, there's lots and lots of, lots and lots of Greek letters, let's put it that way. And a lot of that kind of thing that's the framework of really doing that heavy lifting for you. And the feedback that we've had from people is that they wanted optionality there. So all along we've had TensorFlow, or what we call TensorFlow Core, doing that. But Google Research have a framework called JAX that you may have heard of. Now, JAX is designed specifically for numeric computing. If you want to do math and you want to do it really, really, really fast on an accelerator, then JAX is your friend. But it's not the top layer. It's not a friendly API for defining neural networks. So the goal was for us to say, hey, can we have a friendly API for defining neural networks in Keras, and then plug JAX into the back end for people who want to do that and have accelerators? Then yes, of course. And then there's PyTorch. PyTorch can be an optional backend to that as well, that if you wanted to do your training on PyTorch, or if you've got legacy code in PyTorch. And we also want to make it open for anybody else in the future who'd be building frameworks, because there may be more coming online, to be able to do that heavy lifting of the machine learning. And then at the bottom, of course, is the optimized runtimes for your ML workloads, as I was talking about earlier on, whether you want to run it on an embedded system all the way up to the cloud. And that's what we've been doing at TensorFlow for many, many years now. So Keras Core is new as of a couple of weeks ago. And the goal behind Keras Core is, regardless of what backend you're using, then your code is going to be the same. Like this code that I'm showing here is very, very simple code for, I'm trying to remember what this is. It looks like it's for a thing called MNIST, which is one of the hello worlds of computer vision. But the code is the same regardless of the backend that you're using. So you have that optionality. If you don't like us and you want to work with PyTorch, you can still do it with Keras on the front end. So that's one of the big new things as a framework that we've shipped since I/O. But I wanted to talk about the model users that I spoke about earlier on. And today the model users are primarily developers, but I see the trend of the future being, looking a little bit like this, that as the population grows, more and more of the model users may not be developers. And we're seeing this a little bit as people experiment with ChatGPT and Bard. And these are people who, if I take a step back for a second and I think about what's a developer, right? A developer is somebody who writes something to tell a computer to do something. And typically that's something that we write to tell a computer to do something is code, be it Python or C or whatever. But one of the things that we're seeing more and more now is people writing English queries or prompts in order to tell a computer to do something. And those people are also considered model users. Now today, those model users might be just in a single chat session to be able to, write an essay or to help with something. But you can see in the not too distant future that, being able to prompt a computer to do something using plain English will be one of the ways that people will be able to build applications. And what happens when those model users get more and more and more? Right, so the economy that we have of today is built on 30 million developers, but what if there are 300 million people capable of building solutions using computers in the not too distant future? What's the impact that's going to have on the economy? What's the the next trillion-dollar company going to be? It's probably going to come out of that space. And so, of course, at Google, we support developers, and our vision is to support developers in this space. And one of the things that we've launched at I/O for that is something called MakerSuite. Now, the goal behind MakerSuite is to make it as easy as possible for you to be able to build applications using plain English. So I'm going to show an example in a moment of, this is just a video of where what I've done is using the Palm API, which is the front end to one of our back end large language models. You can, with just a few prompts, tell it how to behave. So there are a number of demos out there that you can play with. One of my favorites is you can tell it how to behave like an alien that lives on the planet Jupiter. And you just give it a few prompts and it will figure out what you mean from that. Almost like, if you're playing you're playing an imaginary game with your child, and, you tell your child to be, okay, you're going to be a Jedi Knight who's good and who wants to defend the light side of the Force against the bad guys who are the Empire. And your kid has seen Star Wars and all of the Star Wars movies and TV shows, and they can figure it out for themselves, and then they can role play that thing. It's a little bit like that when you do what we call prompt tuning a large language model. And so the idea behind MakerSuite is, it's one of the first tools that we've put out there. We're continuing to work on others. And here's a quick demo. So prompt engineering is how you're going to do that with prompt design and prompting. My demo broke. Hang on. I don't know why my GIF keeps breaking. Sorry, just one second. Sorry, I'm going to stop sharing my screen for a second. This demo keeps breaking. I have an animated GIF for it. Let's see if I insert image, upload this one. Here we go. So this one is an application of summarizing text. So I created these 3 pieces of text, and then I summarize them myself manually. So for example, Williamsburg is a thriving artsy neighborhood was a piece of text. I then summarized that text into bullets. And then I, just did that 3 times, and Palm was able to figure out from that what I mean by summarizing text. And then, sorry, it's moving a little fast, but then what I did was with those 3 examples, then Bard figured out, okay, this is what he means by summarized text. So then I input another piece of text about the printing press in Gutenberg just to test it for myself. And Palm was able to understand my intent was that I'm building an application for summarizing text. So it actually summarized the text and then generated the code here for me to be able to do that. Animated GIFs are funny like that. So you can see here I've input passages like buying a car, Williamsburg's a thriving thing, Isaac Newton was a mathematician. On the right, you can see the output that I said. And now I test it with a piece of text about Gutenberg. It outputs, when I hit run, some details about Gutenberg. When I preview this is giving me the prompt. The prompt includes all of my inputs and outputs to define the behavior, and then my desired piece of text. I pass that in one shot to the model. This is the code to be able to do that. And now the model has become a summarization engine. In the past, I would have had to write a lot of code to be able to do that. Now I can train a model to do it, a large language model with just a few prompts. And so that functionality has been done for me. And now if I want to build an application that wraps that functionality, I can do that with JavaScript, JSON, Python, at least to do the calling of the back end, but I can build an application around it however I like. And that's part of the idea of the tooling for these, but we're really, really only getting started. And that was pretty much everything that I wanted to cover today. It's like, you're the developers, you're the ones that are out there thinking about how this is going to happen. You're the ones out there building it. And don't get lost in the hype, particularly around AI. It is just a tool. I used that as a noun just now. Sorry, guilty. But machine learning is the technique to allow you to build AI solutions that are AI is the concept. And you as a developer have these legacy engineering tools, for want of a better term, that allow you to build applications that you can combine with neural networks and you can combine with machine learning to build a whole new classes of solution that weren't previously possible or feasible, like game face. But now there's this whole new class as well on top of that, where in the not too distant future, I think the world is going to look like this. And the developer circle here is small, but that doesn't mean it's less important. In some ways, I think it's more important. And I should have drawn these as cogs instead of as circles, because when it's cogs, the small cog can move the larger cog. And so your skills as a developer are going to be more important than ever. And with that, I can wrap up. And I know we're running a little late. Sorry, I can take a few questions.
Thank you. Great, thank you so much for the presentations. Yeah, we have a few minutes for the Q&A. I hope you, for those, if your questions, you probably come up to here. We have the mic here. I guess that one should be able to. You should be able to hear the questions. Please, anybody have questions? Just come up to the. You can line on the mic before the microphone. You can probably take 3 questions. Yeah, go ahead. Oh, probably need to know. Are you able to hear?
I can hear you, but I can't hear the person asking.
Oh,
sorry.
Can I say it again? Maybe.
Yeah, can you hear me now?
I can.
Okay, go ahead.
So I have a question about your estimations on the timeline. Being up where you are in Google, do you have kind of an estimate of when that mass adoption outside of developers will occur for model usage, or is that 2 months down the line, or are we going to continue playing with models to ourselves for a while?
Of course, we can always continue playing with models for some time. I think that as the developer circle and the MLE circle is much smaller than the model user one. At the end, that timeline, to answer your question, I would say is within 5 years. But please don't see it as that, the developer circle being small, meaning it's less important and we won't be playing with models. In some ways, I think it's escalating the importance of the MLE and the developer. Like I said, like the small wheel in a cog can move the larger wheel in the cog. But I would say that, the advent of the 300 million, this whole new breed of developers, my guesstimate for that would be within 5 years.
Cool, thank you very much.
Thanks.
Hey, do you have any recommendations or resources on how people can stay involved with the AI community, as well as how it's continuing to develop?
So recommendations on how people can stay involved in the AI community as well as it's developing. Well, meetups like this one, I think are good. So most of the big tech companies generally have user groups. Like at Google, we got things called GDGs, Google Developer Groups, as well as TFUG, TensorFlow user groups, both of which heavily invest in AI. If you're a student, many universities have what's called DSC, which are developer student clubs. If you don't have one in your university, then you can apply to actually host one. My son used to host the one in Seattle Pacific University, but he's graduated. I don't know if they're still running one. I don't know if there is one in UW. Similarly, Microsoft, Meta, Apple generally have user groups. Apple tend to do them in their stores, which are all over the place, which is a great idea. And I would say that's the best way to be and to stay connected.
Thank you.
Right.
Okay, probably come here a little bit closer. Okay, our last questions.
Yeah, I'm wondering who the Keras core is aimed to, and the general, the idea for what kind of usability it is for, what kind of granularity do you have with the transfers that you're going to be playing with?
Sure. So I'd say Keras Core is primarily aimed at two sets of people. Number one is the software developer who wants to, have a simple framework for building models, right? In the same way as Keras always was. The second one would be for the ML engineer who wants to crack it open and go a little bit deeper. If they want to be able to build their own layer types. Are you familiar with Keras at all?
Yeah,
Okay,
yeah.
so then you're familiar with how Keras defines things in layers, right? You've got dense layers or convolutional layers or RNN, those kind of things that the functional API that allows you to crack them open and to create custom training loops and that kind of stuff if you want to go that little bit deeper and a little bit lower. And then once you've done that, it will still sit on top of TensorFlow Core, JAX, or PyTorch for the actual heavy lifting of, adjusting the weights in training.
So does it fail at certain levels, like getting as low as you can with PyTorch or as low as you can with JAX?
So I think it can get as low as, I consider the Keras functional API to be very similar as PyTorch for getting low. JAX is not really designed for getting low with machine learning. It has to be combined with a machine learning model definition framework like Flax or Stacks or Heroku to be able to do that. And the idea of Keras Core is to allow you to have Keras be that unified front end, so you don't have to go off into Flax or Stacks or Heroku. And also, when you take a look at things like Flax and Stacks, they're version 0.1. They're very brittle. They're very cutting edge. And if you're building for production, right, if you're going to your boss and saying, I want to put this in production, but it's open source in version 0.1, you're going to have a difficult conversation. So the idea is like, Keras is a much more mature framework. So if you wanted to do your modeling with that mature framework, then you could still do the training with JAX, and you can still, with the functional API, get pretty low.
One quick thing, I guess. For the game face project you showed, is there like a kind of log of how they developed it? Just like walking through this kind of paradigm of combining all three sectors that you showed.
Good question. I'm not sure. I just take a look at the GitHub repo. I think that would be a good start. It was built using models that we deliver via something called MediaPipe. And if you go to mediapipe.dev, they have the in-depth detail on how the MediaPipe models work. So I'd say between the two of those, you'd be able to get that. I hope you'd be able to get that step-by-step look at how it was done.
All right, great. Thank you so much. Let's go around our